Is this a convergent or divergent series? Let us remind ourselves of a theorem that we proposed. The theorem says if you have a series and it is convergent series, then the limit of an, or the limit of the general term as n goes to infinity, must be equal to 0. Out of that theorem, we got an important convergence test. Our test is if the limit of general term as n goes to infinity is not 0, then for sure you can say that then the series an, n starts from 1, goes to infinity, is a divergent series. Very good. So let us begin. This is our an. This is the general term of the series. Let us find the limit of an as n goes to infinity so we can analyze the series. This is the limit of k squared divided by k squared minus 2k plus 5 as k goes to infinity. Very good. So what do we have here? We have the limit of k squared divided by k squared minus 2k plus 5. Can you apply L'Hopital's rule? Yes, of course. Why not? Since you have infinity over infinity, you can apply L'Hopital rule. This rule says you can take the derivative of the numerator, derivative of the denominator, and the limit of an is equal to, as n goes to infinity, is equal to the limit of k squared, which is 2k divided by 2k minus 2 as k goes to infinity. But if you plug in infinity again, you get infinity over infinity. You can reapply L'Hopital's rule. So this limit of an as n goes to infinity is equal to the derivative of 2k is 2 divided by the derivative of 2k minus 2, which is 2. So you get the limit to be 1. So we found the limit of the general term. The convergence test says if the limit is not 0, for sure you can say that the series is divergent. So since the limit of the general term is not 0, so the series is a divergent series. Common mistake for students. Students usually have these mistakes on the exam. Student write, since the limit of k squared divided by k squared minus 2k plus 5 as k goes to infinity is equal to 1, so the limit exists and the series is convergent. It's a mistake. Another common mistake on the exam is they answer a wrong question. So another common mistake The question says, is sequence k squared divided by k squared minus 2k plus 5 is convergent? The question is about sequence, and then a student write since the limit k squared divided by k squared minus 2k plus 5 as k goes to infinity is equal to 1, and it is not 0. So the sequence is divergent. It's another common mistake that we see on the exam, everyone. So students answer wrong question. In the first common mistake, student writes, since the limit is equal to 1, so the limit exists and the series is convergent, which is not correct. The convergence test for a series saying that if the limit of the general term is not 0, then the series is divergent series. And the second type of mistake that we see on the exam is we give them a question about a sequence. We say that, hey, is this sequence a convergent sequence? And then they take the limit is 1. So you can say that, hey, the sequence is convergent, and then answer the question about series. There is no series involved here.